Okay, YouTube, in this video I'm going to continue my series on videos where we're solving quadratic equations using roots, okay? Go ahead and take a look at these two examples that I've written here. I want to solve both of them for x. And you'll notice this, it's actually convenient to solve these using roots because we have something that is being squared, okay? So like in this instance, on example number 1 here on the left, we say x plus 5, that parenthetical quantity is being squared. But we have no other x's besides the one that's listed inside this set of parentheses. So what we can do is we can isolate this set of parentheses, and then we could just use a square root to eliminate our squared. So just to kind of give you an example of what this looks like, what we'll do is we'll say, okay, so x plus 5 is being squared. We need to eliminate all other things on the same side as this squared quantity, which includes this 1/3 times the parenthetical quantity here. So what we're going to do is this. We're going to do the opposite of multiply by 1/3. We're going to divide by 1/3. Dividing by fractions, however, you know, when you divide by a fraction, you end up multiplying by the reciprocal. So what we're going to do is we're going to take both sides times 3. So take this times 3, we'll take the right side times 3, which you notice is this 3 and 1/3, they cancel out, and here's what we're left with. On the left-hand side, we have x plus 5 quantity squared, and on the right, we have 7 times 3 is 21. So now that we have this squared quantity isolated, just like we've done in previous examples, except for it's just a parenthetical quantity that's being squared, we can actually undo the square root with the square root. So we'll take the square root of the left-hand side and the square root of the right-hand side. So we get this. The square root of something squared, the square root and the squared, they cancel out. Okay, and we get left with x plus 5 on the left. Just x plus 5. And on the right here we have plus or minus. Okay, so this is important. Plus or minus radical 21. So, and it's plus or minus, recall, because, you know, the square root of a positive number has two roots, a positive root and a negative root. And if you don't know that, then let's get used to that. But we have one more step to take, and that is to isolate the x by subtracting 5 from both sides. Now this is important. When we subtract 5 from the right-hand side, you know, we could write plus or minus radical 21 minus 5, but it's much more convenient to list this as negative 5 plus or minus radical 21. So a couple things I'd like to say about this. First of all, that this has two roots. The first root is negative 5 plus, radical 21. And it also has the root negative 5 minus radical 21. So when you're learning these, it's good to go ahead and start getting used to writing them out the long way instead of the plus or minus notation. I also want to convert these to decimals. So we're going to take a look at a calculator, how you would do this. But we say negative 5 plus radical 21. Okay, so we have negative 5 plus square root of 21. And we have negative 5 minus radical 21. Those are our two roots. So now taking a look at these decimals, we get first decimal is about negative 0.417. We'll call it about negative 0.42. And the next decimal is about negative 9.58. So negative 0.42, negative 9.58. So let me flip back over here. So we have x is approximately negative 0.42-ish and negative 9.58. Now, I bring this up, these decimals, because what we're going to do is we're going to graph the original function. So now the original function, recall, was 1/3 x plus 5 quantity squared, and this was actually equal to 7. Keep in mind, however, though, that if we were to set this equal to 0, that's what we're interested in doing. Often when we factor things, we set it equal to 0. This is a prime thing that we do here as well. So if we subtracted 7 back over to the left-hand side, we would get this. We'd say, well, the entire left-hand side would still be 1/3 x plus 5 quantity squared, except for minus 7, and this would be 0. So really what we're saying here is we're saying y equals all of this in vertex form, and this is really like saying y is 0. So when y is 0, what we found out was this. When y is 0, we get x values of negative 0.42 and negative, negative 9.58, 0 when y is 0. So we're going to take it over to GeoGebra here. We're going to graph this. Keep in mind, though, this is in vertex form, so we say like the a value is 1/3. We know it opens up and it's wide. We say the vertex is at h and k. You know, hopefully this making sense to anybody that's seen any of my other videos. But we say negative 5, 7. So when we graph this, you know, we actually know quite a bit about it already. But we say, okay, so 1/3, 1/3. So we have 1 divided by 3 times quantity x plus 5, I had to think for a second there, quantity squared minus 7. So we're going to have to zoom out a little bit here. We can manipulate this. Whoa, well, not what I meant to do. I actually grabbed an axis there, but we said, okay, so check this out. We have our vertex at negative 5, comma, negative 7 down here. But what we're really saying is this: when we find the solutions to a quadratic function, what we're really finding are the x-intercepts. Okay, so take a look at this. We say, well, we got an x-intercept here and an x-intercept here. But if you look up here on the right, you'll notice that those are the same two intercepts that we had found previously. Okay, so I just want to really emphasize the fact that when you solve a quadratic equation, what you really are finding are the two intercepts for the function. So negative 9.58, comma 0, and negative 0.42, comma 0. So let's go ahead and take a look at this other example, example number 2, right over here on the right. So go ahead and get this party started. Again, you know, this is really a video about solving, you know, things using roots. So let's go ahead and get to the method for doing so. We say we have a squared quantity right here. It's a parenthetical quantity, but yet it is squared. So we need to isolate this. That means our minus 6 has to go and our times 1/5 has to go. So we're going to go ahead and add 6 to both sides. So we'll kick the 6 over to the right, and we have this left over. We'll switch back to blue here. 1/5 quantity x minus 4 quantity squared is equal to 6. So now we need to do the opposite of multiply by a fifth, which is divide by a fifth. But again, that's the same thing as multiplying by the reciprocal when you divide by a fraction. So we'll take the left times 5. We say, okay, so x minus 4 quantity squared is our squared quantity, and that equals 30 in this instance. So now to eliminate the squared, we'll do a square root. And so we get this. Square root of x minus 4 squared is just now x minus 4. And on the right here we have plus or minus radical 30. So I'm trying to think here, what factors are, you know, going to 30? Are there any that are perfect squares? Well, 4 doesn't go into it evenly, 9 doesn't go into it evenly, 16 doesn't go into it evenly. So this is as simple as you're going to get this radical 30. So now the only thing we have left to do is just add 4 to both sides. So we get x equals positive 4 plus or minus radical 30. Okay, and again we could say this is x equals 4 plus radical 30 and also 4 minus radical 30. And as a matter of just getting into the habit of doing so, let's go ahead and find these on a calculator. Say 4 plus square root of 30 equals, and then 4 minus radical 30 equals. So we say our two roots are roughly about, I'm going to go to the nearest tenth here, about 9.5 and negative 1.5. Okay, so negative or positive 9.5 for our first root here. This is approximately 9.5, and negative 4.5, I think, is what we had. Let me check. 1.5, not 4.5. So 1.5, pardon me. So negative 1.5. But again, just to re-emphasize this, if we were to graph the original quadratic function, we'd see that it strikes the x-axis at these two intercepts. So again, solving using square roots just means isolate the squared thing, and then we'll use a square root to undo it. Cheers.